Have you ever driven across a bridge and felt completely safe without even thinking about the invisible army working underneath to keep it that way? What you're about to discover is the hidden world of bridge maintenance, a world where engineers, technology, and time itself collide to keep millions of lives safe every single day. Every bridge you cross is more than just concrete and steel. It's a living, breathing structure that demands constant attention. Think about this. In the United States alone, nearly 60% of all bridge failures are linked to something called scour. That's the erosion that eats away at the foundations buried deep beneath fast-flowing water. That single statistic explains why bridge maintenance isn't just a routine job, it's a matter of survival. Long before any visible damage appears, the process of protection has already begun. Teams of highly skilled engineers carry out scheduled inspections monthly, quarterly, or annually. They're not just looking for obvious problems. They're searching for subtle shifts, hairline cracks, and the first signs of corrosion, often before the human eye could ever detect real danger. High-definition drones are a huge part of this. They hover beneath massive spans, capturing thousands of incredibly detailed images of cables, joints, and decks. Every single frame is then analyzed with artificial intelligence, which can spot irregularities and potential weaknesses that might otherwise go completely unnoticed. After the drones do their work, ultrasonic sensors are often deployed. These are small devices that send sound waves straight through solid steel to detect microscopic fractures hiding inside the beams. When the readings from these sensors change, even slightly, engineers know that something deeper is happening. It's an early warning sign, a quiet alarm bell that rings long before the threat of collapse becomes real. The data they collect is fascinating. For instance, if a bridge foundation's depth decreases by just 30% due to scour, its natural vibration frequency, the way it gently sways, can drop by nearly 40%. To an engineer, that's a massive red flag, signaling that the structure is weakening below the surface. It's this kind of precise data that allows maintenance teams to act fast, intervening long before failure ever becomes visible to the public. Once these hidden weaknesses are identified, the real work begins. Steel surfaces are blasted clean, stripped of every particle of rust, and then coated with powerful protective layers of epoxy and polyurethane. These aren't just ordinary paints, they're advanced coatings strong enough to resist salt, moisture, and extreme heat for decades. On the road surface, concrete decks are meticulously sealed. This process blocks chlorides from saltwater and dicing chemicals from seeping in and corroding the steel rebar that forms the bridge's skeleton. Meanwhile, underneath the water, specialized divers get to work. They remove built-up debris and sediment from around the piers, and in some cases, special grout mixtures are injected deep into the riverbed to stabilize the foundations against the relentless push of shifting currents. But the work doesn't stop there, because environmental stress is a silent, constant destroyer. Think of the salt-laden air in coastal areas, the constant vibration from traffic, the freezing winters and scorching summers. To fight this endless battle, engineers follow proactive maintenance schedules instead of just waiting for damage to appear. Studies have shown that bridges that are cared for regularly can cost up to 50% less to maintain over their entire lifetime compared to those that are only repaired after problems become obvious. In coastal regions, corrosion is a particularly aggressive enemy. It can eat through unprotected steel at a rate of several millimeters a year, a slow, invisible threat that spreads like a disease. To counter it, crews apply what are known as sacrificial zinc coatings and advanced anti-corrosion paints. These layers act as a shield, essentially sacrificing themselves to protect the steel underneath and extending a bridge's lifespan far beyond its original design limits. Some bridges, especially those crossing deep rivers or vast bays, face even greater challenges. Their foundations are constantly under attack from powerful water movement. This requires specialized scour countermeasures, like placing massive riprap stones around the base, laying down concrete mattresses on the riverbed, or even building armored layers to shield the piers from erosion. These defenses aren't just built once and forgotten. They are inspected and strengthened regularly, ensuring the bridge remains anchored firmly to the earth below. Bridge maintenance today is nothing like it was 50 years ago. It's no longer just about patching some concrete or repainting a few beams. Modern bridge care is a complete, integrated system, a sophisticated combination of robotics, data analytics, and irreplaceable human intuition. Autonomous crawlers, like something out of a science fiction movie, travel along decks and cables, scanning every inch with laser precision. Ground-penetrating radar is used to map the bridge's internal condition, detecting hidden voids or delamination deep within concrete layers that would be impossible to see from the outside. So much of this critical work happens completely out of sight. It takes place at night, under the glare of floodlights, while our cities are sleeping. Crews are out there welding, tightening bolts, and replacing bearings in the quiet of the night, all to ensure that traffic can flow smoothly and safely the next morning. Every single bolt that's retightened, every joint that's replaced, and every sensor that's installed adds years, sometimes even decades, to a bridge's life. Because of this relentless effort, structures that were once designed for 50 years of service are now pushing 80 or even 100 years. It's all thanks to the incredible power of maintenance. The cycle never ends: inspection, detection, repair, and monitoring. It's a constant rhythm of prevention that keeps our nations connected and moving. Engineers track detailed condition ratings and run predictive models on computers to determine exactly when and where to intervene for maximum effect. Because if you wait until you can see the cracks, it's already too late. By then, the costs have skyrocketed, safety has dropped, and a full closure for major repairs becomes almost inevitable. Technology has been the ultimate game changer in this field. Drones and robotic crawlers can now inspect places that are far too dangerous or inaccessible for humans. Underwater cameras and sonar systems map foundation scour in real time, giving engineers a live view of what's happening beneath the waves. And all over the bridge, an array of sensors, vibration sensors, strain gauges, and temperature monitors are constantly at work. They feed a continuous stream of data to control centers that are watching over these vital structures 24 hours a day, 7 days a week. From the surface, it all looks so peaceful, just cars, lights, and movement. But beneath that calm exterior, there is constant, unwavering vigilance. It's a silent orchestra of data and human expertise, all working together in perfect harmony to fight the one enemy that every structure on Earth faces: time. Bridges are true miracles of engineering, but even miracles need care. Each inspection, each weld, and each drop of protective paint is another layer of safety for the millions of people who may never think twice about the incredible structure holding them up. So the next time you drive across a bridge, take just a second to look beyond the view. Remember the divers working deep in the water, the welders suspended under the deck, the drones buzzing in the air, and the data flowing silently through hidden sensors. They are the unseen guardians, the reason that bridge stands strong and tall today. Because the greatest bridges in the world aren't the ones that were built the fastest. They're the ones that are maintained the longest, cared for by dedicated people you'll probably never see, but depend on every single day. Thanks for watching, and if you found this look into the hidden world of engineering interesting, don't forget to like and subscribe for more.